Alright guys, welcome back to Underground Science, and in this video we'll be going over iron deficiency anemia. Alright, so first of all, let's just go and briefly talk about what the definition, right, what the quick overview of the definition of anemia is. Alright, so pretty much anemia you can classify as, or you can split into two separate definitions or two separate bullet points, is that it's either going to be a lack of red blood cells, right? Lack of red blood cells, or it's going to be a lack of hemoglobin. All right. So that's pretty much that's just the two main things to remember about the basic definition of anemia. All right. So in this video, let's go and discuss the first type of anemia, right? Or one type of, it's a very common type of anemia, which is iron deficiency anemia. So as the name suggests, you get this anemia because of not having enough iron, all right, in your blood. So let's say we have a red blood cell here, all right, so let me go and draw a red blood cell like so, all right, and so inside our red blood cells, we know the basic structure of it is that, of course, we have our glycoproteins, our glycoprotein on the outside, right, representing our blood type, but in the inside, right, we have many hemoglobin, right? So we have many hemoglobin on the inside. And so remember, we have two alpha and two beta chains, right, making up our hemoglobin chains, our globin chains. And inside those hemoglobin, we have iron heme groups, right, in each hemoglobin chain. So, I mean, in each globin chain, right, alpha and beta chains, we have iron heme groups. All right, so in these iron heme groups that we have, right, so this is going to be one hemoglobin in green, and these are going to be our four globin chains, two alpha chains and two beta chains. All right, and then inside those chains, right, we're going to have heme groups, iron heme groups, and that's where oxygen will bind, right? But in iron deficiency anemia, because we don't have sufficient amount of iron, we can't make those heme groups, right? And if we can't make those heme groups, we see that the number of hemoglobin, right, actually decreases inside our red blood cells. And if the number of hemoglobin decreases inside our red blood cells, then that means we can't carry adequate amount of oxygen throughout the body. All right, so what happens is that iron, right, that we eat from our diet, and so iron will actually eventually come to our red blood cells, and what's going to happen inside our red blood cells is that iron will react with a pigment molecule called protoporphyrin 9, all right? And protoporphyrin 9 and iron will react together to form heme, all right? Our heme groups. And well, it's also the products, we're gonna have some hydrogen protons, but right now let's not worry about that. We're gonna have heme, right? And that heme is then gonna be used inside our globin chains, so that eventually oxygen will be able to bind, all right, to our iron heme groups. However, as you can see here, right, if we don't have enough of this iron, if we don't have an adequate amount of iron, hence iron deficiency anemia, right, then that means we don't have enough iron to react with protoporphyrin 9 to make heme, which means that we can't have enough functional hemoglobin. So we're not going to have enough functional hemoglobin, because remember, heme is an integral part of hemoglobin. So if we don't have enough heme, we don't have enough functional hemoglobin. And if we don't have enough functional hemoglobin, remember, hemoglobin has those heme iron groups inside those four globin chains. Usually oxygen binds to hemoglobin as the form of oxyhemoglobin, right? Like we discussed in the Bohr-Haldane effect, oxyhemoglobin. But if we don't have enough functional hemoglobin, not enough oxygen can bind, so overall, it's going to lead to decreased amount of oxygen going to tissues, right? Going to tissues and other parts of the body, right? So our muscle tissues, fat tissue, and all the other cells in our body, right, that need oxygen, that need an adequate amount of oxygen to survive. All right, so, and one thing I want to mention is that when we react iron with protoporphyrin 9, we don't just make heme by its own, we need a catalyst to drive this reaction. So let's go and mention that catalyst. So that catalyst is going to be called ferrochelatase. All right, so ferrochelatase or chelatase, ferrochelatase. All right, so can't spell it today, sorry about that. Ferrochelatase. And so ferrochelatase is going to be our catalyst that lowers the activation energy for this specific step, so that helps this reaction go forward in at a faster rate. All right, so it's our enzyme that's going to help react protoporphyrin 9 to iron and then form heme, which is a functional part of our hemoglobin as a whole, right? In our globin chains, in our alpha and beta globin chains that make up hemoglobin, we have heme iron groups inside there. That is where oxygen binds to. And then we said that if we don't have enough heme because we don't have enough iron, we don't have enough functional hemoglobin. And we said that the main part in a red blood cell is a hemoglobin. Because we don't have enough functional hemoglobin, guys, iron deficiency anemia is also going to be classified as microcytic anemia. And it's microcytic anemia because our red blood cells, because of the decreased amount of functional hemoglobin, are not as big as they were normally anymore. They're actually smaller than their normal size. That's why it's called microcytic anemia. And there's actually a certain a range for it. So this range is about, you can say, from 85 to 95 femtoliters is where we determine if you have microcytic or macrocytic anemia. So if it's less than 85, so if your mean corpuscular volume, right, so the total, in this case, that represents the total size of your red blood cells, if the mean corpuscular volume is less than 85 femtoliters, then that means it's classified as microcytic anemia, right? So microcytic anemia. And in the future videos, when we'll see some anemias that are macrocytic, right? Which means, so let's just go and write that down. If the mean corpuscular volume of your red blood cells is greater than 95 femtoliters, sorry if my fives look like S's, don't know why that happens sometimes. Let me go and retry. So if our mean corpuscular volume is greater than 90 femtoliters, it's going to be classified as macrocytic anemia. All right. So our mean corpuscular volume is just another way of determining and seeing the size of our red blood cells, right, in femtoliters. And if it's a certain size that's below 85, then we see microcytic anemia. If it's a size greater than 95, it's macrocytic anemia. Iron deficiency anemia is microcytic anemia because we don't have adequate amount of iron, which means we can't produce much heme. Heme is an integral component of our hemoglobin because we have heme iron groups in our globin chains, our alpha beta globin chains, which is where oxygen binds. So if we don't have enough heme, and heme is an integral part of our hemoglobin, that means we won't have enough functional hemoglobin. So if we have less hemoglobin than in our red blood cells, we have a decreased size in our red blood cells, which is going to be classified as microcytic anemia, again, because it's less than 85 femtoliters. And it's going to lead to decreased oxygen going to your tissues, right? If you have decreased oxygen, you might have an elevated heart rate, you might have shortness of breath or dyspnea and many other symptoms, all right? So you might feel tired also, and there's many more symptoms also for iron deficiency anemia. So one thing that you could do to make this iron deficiency anemia better is just increase the amount of iron in your diet. All right, so this is what the science says, and I hope this video made sense to you guys. So this is the end of this video for iron deficiency anemia. Make sure to tune into my future videos where I'll talk about more cool topics about biochem, physics, and chem. And don't forget to hit that notification bell, like, subscribe. See you guys later, and stay safe.